all. Today we're going to talk about the power to a power property of exponents. So when you see a power to a power property, we are thinking something that it's not the distributive property, but it looks similar to the distributive property, and I'll show you what that means in a few. So here, notice that we have our base of x to a second power, then it's in parentheses, but outside we have those parentheses, we have a 5, okay? So we're kind of doubling up, they're kind of buddying up a little bit. So our base is x, and we have a power of 2, but we have to take it to the 5th power. So that looks like x squared times x squared times x squared times x squared times x squared. There are 5 x squareds, okay? 5 of them. So whatever our base in this case of our x squared to the 5th power, we write that 5 times. But we know from simplifying these and doing expanded notation, we can break that down further. So this x squared is x times x. This x squared is x times x. This squared is x times x. This squared, x times x. This squared, x times x. So we're still multiplying everything. So that is what it looks like in expanded notation. And if we go ahead and count our x's, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, we will see that we will have 10 of those x's that we are multiplying. So it would be 10, or x, got our base of x to the power of 10. But that's really cumbersome. That takes a lot of energy. So there's a nice easy way to do this, thankfully, for this power to a power property of exponents. We just can multiply the exponents. So like I said, when we draw these arrows, and you'll see when we do a more complicated problem, that, you know, it looks similar to our distributive property, but it's really cross multiplication. So we take this 5 and multiply it by the 2. So 5 times 2 is 10. So my base of x and 10 as my exponent, x to the power of 10. So all we need to do is take this 5 and cross and multiply it to everything that might be in those parentheses. Okay, but either way, we get x to the power of 10, x to the power of 10. It just takes you a long time, especially with a complicated problem, to do that. But let's take a look at something that is a bit more complicated. Okay? Oop, come on, let's refocus it. There we are. All right, so power to a power. So remember, we can take whatever this exponent is on the outside and multiply it by all of our bases on the inside. So for this one, this is where a lot of people get tripped up, so be careful with this. So you figure, well, I don't need to do anything with the 3. It doesn't have an exponent. But remember, our x equals something, that coefficient or that number in front of x is 1, even though we don't write it. So when we do this, it's like we're saying 3 to the 1st power, a to the 2nd power, b to the 4th power, and then all of this to the 7th power. So I will go ahead and put my arrows so I know that I'm matching everything up. So I take my base of 3, my base of a, and my base of b. So 7 times 1 is 7. 7 times 2 is 14. 7 times 4 is 28. So there we have our simplified version. We could technically go one step further and apply this exponent of 3 to the 7th power. So I can just get my calculator out. Now, once you get into some really large numbers, it doesn't make a lot of sense, but 3 to the power of 7 isn't super big. If you get here, we're happy, but if you want to make that extra step and maybe work with some scientific notation, that would be some good practice too. Okay, and we just rewrite everything else. So 3 to the power of 7 is 2,187. And because we don't know the value of a or b, we just have to leave them as the variables. So 2,187, a to the power of 14, b to the power of 28. So like I said, even though it's called multiplication, it does look like a distributive property. It's just a way for us to kind of hit back on what we need to do because we are multiplying, okay? We are multiplying these exponents. And remember, when there isn't an exponent that's associated with it, like this 3 initially was, it's to the power of 1. You gotta remember to write that. All right, so let's take a look at some practice. So we are going to simplify using the power to a power rule. So once I get it centered for you guys, I'm just having a rough morning. All right, so we have n to the 4th power, then all of that to the power of 8, 3 to the power of 4, which is then to the power of 6, and 2m to the 4th power, n to the 10th power, which is all to the power of 3. So remember what we talked about when there isn't an exponent. Okay, go ahead and pause this video and try these out on your own. All right, so let's take a look at our answers. So for this one, remember we would just go ahead and multiply those two numbers. So 8 times 4 is 32. We don't know the value of n, so we just leave it as n to the power of 32. So my base here is 3, okay? 3 to the 4th power to the power of 6. So we go ahead, once again, multiply our exponents. I know we didn't go over one that looked just like this, but hopefully we were able to extend our thinking. Our base is 3. And our exponent, which is 6 times 4, is 24. Now, when you put this in a calculator, you get scientific notation. So if you just want to leave it as 3 to the power of 24, that is fine until we get a little bit more practice with scientific notation. But just so you know, it would equal approximately, because they still round these numbers sometimes, so we don't know how far it goes on. So approximately 282,429,536,500. Okay, so approximately. So if you did that in scientific notation, you would have not seen those zeros, and you would have seen a decimal point maybe between that 2 and that 8. There might have been some more numbers after there, but on my calculator, that is how it read. Okay, so for this one, once again, we need to remember this is to the power of 1, so we still need to do our cross multiplication for this. So our base of 2, our exponent would be 3 to the power of 1, which is 3 times 1, which is 3, so 2 to the 3rd power. M, 3 times 4, which gives us our 12, and N, 3 times 10, which gives us 30. Now this one would be, I mean, you can leave it like that, but if you wanted to go that next step, this one's an easy one. 2 to the power of 3 is 8, M to the 12th power, and N to the 30th power, because we do not know the values of M and N. So if you have any questions, please feel free to contact us.